Just a little bit of background on myself. So I work for Signify. It's a little bit confusing because you see the brand Philips. So Philips is the brand underneath the company of Signify. So we sort of split from Royal Philips about 4 years ago. So it's a little bit confusing, but Signify and Philips effectively is the same thing. So I work for Signify. I've been there around 3 years. I'm their UK marketing strategy manager. I was with E.ON previously, so I had about 10 years with E.ON, but I've always been involved in sort of new technology, and more recently for the past 10 years in lighting, and then that's led me into this kind of new topic of UVC lighting and how we can use that for disinfection purposes. And I'm joined today by Rob, who's one of our what we call certified UVC partners. So we have a network in the UK of people and partners that we work with, and Rob represents UV Technology, who's one of the companies that we work with to help bring these solutions into the market. Okay, so I think we'll agree that that statement's fairly obvious. We all want to keep our people safe, and I think within the healthcare sector, and particularly within hospitals, there is no more important sort of area where we want to keep staff, patient, visitors as safe as possible. And there's an opportunity now to bring an even greater level of safety and health to those premises by deploying what we call UVC lighting or UVC disinfection. So I just want to spend the next probably 20 minutes going through a few topics, a little bit on how the technology works, a bit around the solutions that are available, how we can then apply them in different healthcare facilities, and then finish off with a couple of case studies, and Rob will mention some of the work that he's been specifically doing. So I mentioned Signify, as I said, formerly known as Philips Lighting. We're the biggest lighting company in the world. We've been around for many, many years, and we have lots of people in lots of countries. But the important point here is that whilst the recent events where we've had this big pandemic with COVID, healthy buildings and healthy workplaces is part of our core strategy. So we've been working on this topic for, let's say, 10 years. There's no doubt that the recent events have brought it to another level of importance, and we've then accelerated certain activities, like bringing UVC disinfection to the market. But it's something that we've been working on for a number of years, and it's something that we foresee for the future. You know, there's lots of discussions around sustainability. I think health and well-being will now overtake sustainability as being the most important thing to protect our people. You know better than anybody the impact that it's had, particularly in the healthcare sector, particularly on hospitals, and the task of preventing infection and controlling that within these environments has been, really difficult. And as I said, this is about trying to bring another layer of protection using new technology and new solutions to further help you with that strategy. I guess these are some of the sort of the terms and the problems that you'll come across in your kind of daily work. You've got these hospital-acquired infections, you've got high-risk areas, you've got high bioloads. Everybody's always looking at costs. You've got high-risk wards. All these things are all kind of important when we look at this topic. And I guess as infection prevention control specialists, you're always looking at better ways to improve. We see this having a number of benefits for yourselves and for the facilities. Clearly, there's a need to try and reduce and prevent nasty viruses and bacteria in the first place. So if we can deal with that at source, if we can keep it down to a single patient in a single bed, then we're reducing the chance of transmission, we're reducing the chance of having to close down areas, and ultimately we're saving lives and reducing the cost impact as well. So there's lots of different benefits and kind of advantages in deploying UVC. There's also things like fallow times. So it might be that if you've had an area that's been infected or you've had patients infected, you may have to close that ward for a number of hours, maybe days. By having these solutions and keeping the air and the surfaces clean, you can maybe reduce these fallow times down. And again, there's a cost saving. There's also an element of the overall strategy in keeping the ventilation and the quality of the air in your facilities to the best level. Now you could say, well, let's invest in a brand new HVAC system where we've got, the best clean air throughout the whole hospital. This has a cost. So whilst this is not really a kind of return on investment topic, there is still that cost analysis to consider as well. And ultimately, everything we're trying to do here is about looking after the people. That's ultimately what we're doing. So just a little bit on the signs. Now, I know there was a session earlier that really went into some of the real science of pathogens and how UVC can work. This is a little bit more high level, a little bit more simplified. So when we talk about transmission, we're really talking about two areas. We've got the airborne transmission, where these nasty viruses and pathogens are in the air. And I think COVID-19 has been a really kind of strong example where that aerosol transmission has been quite deadly. So that's airborne transmission, and that's in the air. And then you've got surface. So this is where the particles or the viruses end up on the surfaces around us. It could be the table, it could be the bed, it could be a sink, it could be a piece of equipment. So there we've got this surface transmission, and that really occurs when people pass it from person to person, having come in contact with that surface or that object. So they're the two areas that we're focusing on. But in terms of today and the problem we've got, I think aerosol and airborne transmission is kind of well understood now as being the main problem. So what is UV radiation? So ultraviolet light is part of the electromagnetic spectrum of light. You've got visible light and you've got invisible light. So UV is part of the invisible light spectrum. And within that, you've got UVC, which is very specifically only used for germicidal reasons. So we have to recreate that particular type of light and control it, but only use it for specific medical reasons. And within that actual spectrum of light, there's a very specific wavelength, what we call 254 nanometers. And it's just a very specific wavelength that has been proven to be very effective at dealing with these viruses and bacteria. And the way it works is that as that UV light hits the structure of these viruses or pathogens, it breaks down the structure and effectively renders it ineffective, so it cannot then reproduce and transmit. So when you hear the word kill, it's actually a little bit misleading. It's not killing the virus or the pathogen, it's breaking it down and rendering it ineffective. The technology itself has been around for many, many years. Here in the UK, it's maybe a little bit less known, more commonly used for water treatment. So you may not even see it. It's working away in the back in the water treatment plants. But what it's doing is making sure that the water that you drink is clean and good for you. We don't yet have that situation with air, which seems crazy because we breathe in air all the time. And as I said, it's a very specific wavelength, and we use very specific, what we call lamps or emitters that are produced to create this particular light, and then you build these products into a machine or a device that can then be used for these applications. Quite often we'll be asked, well, does it really work? We get all sorts of questions around, well, have you proven it? Does it work? Can you show me, examples? We've gone to great lengths now to get the evidence with laboratories, with independent researchers, with Intertek, who are one of the biggest laboratories in the world, to absolutely prove that the products and the solutions and the technology works. We've got the reports which we can send links to. And we've done that from sort of two angles. One, we've looked at it from a technology. So in a lab, in a controlled environment, can it be proven to inactivate the virus? Yes. But then when you put it into more of a real world room, which is more realistic, can it also be proven to clean the air? And again, yes, we've got the evidence for that now. So in terms of serving the healthcare sector, we're a traditional lighting company who have now got different business streams dealing with different applications. But for the past 30, 40 years, we have been serving the healthcare segment here in the UK and in the rest of the world with big turnkey projects, with specific lighting for the MRI rooms, big rollout projects across 20, 30 sites. So in terms of that key capability to help healthcare, we have that in our locker for many, many years. And then more recently, we're starting to really see some traction now with the UVC products, mainly in the Far East, a little bit more in the US, and now we're starting to see the traction here in the UK. And that traction has come from 2 or 3 key areas. You've either got the government who are mandating and putting in legislation that you must do something, or you've got the healthcare and the specialists saying, we need to do something to improve, or you've got the companies themselves who are just out there constantly pushing and promoting products. And it's probably a combination of those 3 things that will really help us to get some traction in this new market. In terms of the solutions that are available, so we talked about air disinfection and we talked about surface disinfection, and that's where the different products are aimed to support. So you've got the products along the top here, they're all designed to deal with continuously disinfecting the air. The products across the middle are there and designed to deal with disinfecting surfaces. And then these ones that look like kind of ovens or chambers, they're effectively still cleaning surfaces, but they're done in a way that's contained within like a chamber. So it could be a piece of IT equipment or some small objects that you want to disinfect. So they're the 3 sort of ranges of products. Now that's what we offer. You will see lots of different products on the market, all doing similar things, but they're all trying to achieve the same thing. They're all trying to clean the air, they're all trying to clean the surfaces. I think we acknowledge that aerosol and airborne transmission is the most sort of prominent topic at the moment. So I'll just spend a few minutes explaining the 3 core products that we've got. This is what we call our upper air unit, and this is designed to be mounted either directly onto the ceiling or onto the upper part of a wall. And it creates effectively a zone of UVC light up in that high part of the ceiling so that when the air passes through, it just constantly disinfects it. And there's a little graphic here, assuming it plays, that should just demonstrate what I've explained. So you've got the UVC unit, which is the black box on the wall. You've got the green stripes, which is kind of depicting the UVC zone. And as the air naturally circulates in and out of that space, it's getting a really high dose of UV and cleaning that air from all viruses and pathogens. So it's a really nice, simple, effective way to constantly clean the air. Now again, assuming this plays, this shows a nice model that gives you a real visualization on a room without upper air and a room with. And what it's basically saying is that if you've got an individual person that's infected, he will continually breathe out those particles, but where you've got the UV, it will effectively deal with that at source, and where you don't have the UV, effectively that can then cross-contaminate everybody else in that space. So it's a really nice way to just kind of show what we're trying to explain. We've then got what we call active air, and the only difference between the previous product and this one is that this is a fully contained product that uses fans to force the air through the product. So you could install this on the wall or again on the ceiling, but there's no exposed zone. It's all contained within the device, and it relies on the fans pushing the air through the device. It gets the dosage of UVC inside, and then it emits the clean air from the other side. So a very simple product by design. You've got the fans, you've got the UVC lamps in the middle, and you've got a little bit of filtering. So that's what we call our active air product. And then again, you've got a very similar active air product, but this one is designed to be floor standing, so it gives you that mobile capability. So it might be that you've got areas or rooms that you want to move these devices to and from, this would be better suited. Same principle, the air is drawn in, it's passed through a UV chamber and a bit of filtering, and then it's emitted out through the top. So they're the three core products that we would look to design and implement if it's an air disinfection topic that's important. In terms of how we would apply them into a healthcare facility, when we look at different sectors, so if you take, for example, an office and a hospital, the hospital is already high risk because of its nature. So actually, these devices can be applied throughout the whole of the hospital, and all we'd look to do is to work out which of the products best suits the space or best suits that application in that area. So that's more down to the kind of the size and the infrastructure and what's going on in that space. But because it's a hospital, it's already high risk for transmission and for infections. And same with the surface mount, the surface disinfection. Again, we'd look to pick and choose which ones are appropriate depending on what you're trying to achieve and which areas are important for you. And just to finish on the sort of the application side, so we're already doing I'd say a small amount of work. We're just starting this journey, particularly in healthcare. We're working with 3 or 4 of the trusts across the UK, 3 of them up in the northwest, 1 of them in Northampton, and they've started to deploy these active air products throughout their hospitals. They've started with the kind of intensive care units, some of the high-risk wards, but they've already taken some really positive steps to do something in their spaces. And Rob, do you want to just mention the 3 that you're directly working on?
Thanks, Clark. Just a little bit background about myself and UV technology. We started off 15 years ago trying to convince food companies that your air was dirty, and frankly, they didn't really want to know. And I think COVID has obviously brought into the mainstream that globally we have a problem with air. We take Philips's components and we build these into tunnels to make food last longer, to remove chemicals from processes. Post-COVID, we've been cleaning boxes for Pfizer for shipping vaccines, airport security trays. We all travel through an airport, we pick up a security tray. Nobody thinks, has that been cleaned? It's a high frequency contact surface, and we now clean that with UV. At the beginning of the pandemic, there was a global rush to solve the problem, and we saw a gamut of inquiries from around the world of we need UV. People realised UV was a key tool in the fight against C19, be that airborne or be that surface. We saw lots of inquiries from airports who wanted to clean trays and clean bags, and then airplane travel stopped, so those inquiries went away. And then the market or the requirement matured because we began to understand what we needed to do to kill COVID, how easy it was for UV to kill COVID, and I think that's quite important, is that UVC is very, very effective at killing, inactivating not only COVID, but norovirus, influenza. A piece of UV kit will effectively cover most of those things. If I'm in a food factory and I'm trying to kill a yeast, I need more energy, but we don't really need to worry about that for this instance. And then Omicron came along pre-Christmas, and there was a real panic because we realised that it was much more transmissive than the Delta variant, and there was a race to find solutions, and UV really came into its own. So if we look at examples in the Northwest, within University Hospital Trust throughout Liverpool, Aintree, et al., basically we were deploying kit to COVID wards, not only to prevent patient to staff transmission, which is key because the NHS as an employer has a duty of care to its staff as well as its patients and the visitors, etc. But if we look at something like Queen Elizabeth's Hospital in Birmingham, whereby the specific driver there was the lung function test suites. So they were testing 1 patient an hour that took about 15 minutes. The other 45 minutes was spent purging the air in the room. by simply deploying the floor standing unit that Clark showed, there the little tower, we've reduced that fallow time to basically just under 30 minutes. So now they're seeing 2 patients an hour. So in terms of the NHS's 6 million plus backlog of patients that we need to see for whatever that patient requirement is, their key driver was all about improving footfall, and UVC played a key part in that. Subsequently, we are now, along with Signify ourselves, working on the definition of British standards, and I think going forward we will see that it becomes enshrined in law that we must look after the air in our buildings. We eat clean food, we drink clean water, but we're happy to breathe clean air. Should we really be doing that going forward? And I think in the next 6 to 12 months we will see a defined standard that if you, as purchasers, are buying UV, it must conform to certain standards. And I think it's crucial that we say that there's been a lot of sort of products come to market, question, are they fit for purpose? Some are, potentially some aren't. But I think it's important that you engage with shall we call us the experts, people who have been doing this for years. Philips have been making emitters for 40 years. We've been doing it for 15 years. And we understand the pitfalls, the nuances, and what you should and shouldn't be doing. And I think what we're also seeing as an applicator of UV, where we take emitters and we build them into different solutions, is that when you are building new wards in hospitals or new build sites, UV will become part of the base build, and your architect specifiers, designers will be saying, okay, yes, we need filtration, but we need UV, because going forward we are trying to eradicate the potential spread of the burden on the NHS financially, on the toll it takes on employees, etc., and basically freeing up bed days and reducing the cost. And you know, any advice you need from us, we're here to engage with. Please ask us. This is what we do for a living. We understand it. Don't spend your money on a piece of kit that isn't going to perform, because all too soon it'll be redundant and left at the side of the room. I think that really sort of says it from where we're seeing it from my side of the fence for now, Clark.
And one of the positive steps that we have seen is that the NHS supply chain have recently put in place a framework which has brought together a short list of approved suppliers that they deem can supply the right equipment. And I think there's a process now where they will be contacting the trusts, kind of promoting the framework, and then helping you directly to access it and then get the right solutions and work with the right companies. That is a really positive step, and it's probably the first step in helping engage with, you know, the bigger healthcare sector. And we'll be there to support the individual trusts when they're ready to make a decision or to have a discussion. So, you know, as Rob says, we're here to give that advice. And
just on that point, for those that obviously purchase through NHS supply chain, which I assume most of you do, just for reference, that framework reference is FTS 295. So that's where you'll be able to access the data, the products, and the monies that are available. And I think across the lots, it's somewhere in the region of £50 million. So, you know, the Chief Scientific Officer, who we're working with defining standards, they have realised that air is a key problem to the NHS, and going forward, we really need to start addressing how we best treat our air.
Okay, thanks, Rob.
Thank you.
Just to sort of finish up on the kind of services side. So as with many projects that are deployed across different sectors, there's usually a kind of a bigger requirement, and similar with UVC and UVC projects, there has to be a careful design and planning stage. We have to then make sure it's implemented or installed in the right way. We then need to make sure that during the life of the operation that the right maintenance and care is taken of the system. And then even at the end of that, we can look at recycling and removing those products. So there's a full kind of, what we call kind of turnkey aspect to every project. So whilst there are individual products that could be used, you've got to think about the wider services that go around and make sure you get a full, complete offering. Okay, so just to kind of summarize, hopefully we've given you a little bit of a flavor on how UVC can help. It's not a, it's not a silver bullet. It's not going to solve all the problems, but it's certainly going to give you that extra layer of protection as part of that bigger strategy that can help within your various healthcare facilities. UVC is proven, it's fast and it's effective. So we believe it's a solution that can really help going forward. And as Rob alluded to, you need to make sure you work with the right people, the right trusted partners, and that you get the right services. And if you need support, advice, then we're happy to help. We have lots of information. If you need a bit of bedtime reading, you can go onto the website. There's blogs, there's white papers, there's case studies. There's even a little training path. So if you want to understand a little bit more about UVC, how it works, the benefits, the downsides even, there's a little training path you can follow. And we've got this, what's called a CIBSE approved module. And basically it's part of what's called continual professional development. So if you're an engineer and you want to continue your professional development, you can get accreditations by completing this training. And if you want to know more, we're upstairs. We're on stand number 6, I believe. There's a little team up there that can help answer any questions that we haven't covered today. If you want to know anything more about the solutions and services, then come up and see us. And I think there's a little short video, if I've got time. I think it's only 1 minute long. So let's see if that plays. Yes.